Okay, test 1 2 1 2. We have sound, we have music, we have chat. Yes, do we have chat? So welcome, guys. Sorry about my voice. I'm a bit sick, got a little flu, and yeah. So we are back. We're gonna start the machining series of the parts that we designed for the Milo. Let me just increase the volume a little bit for me. So yeah, I'm sorry if the setup is a little messy. I've been doing in hurry and I didn't want to completely destroy the other shop setup. So I couldn't get the machine running on the inside of, a camera running on the inside of the machine, just because I don't have a wired connection. Hey Joseph, how are you? So I don't have a wired connection to the laptop here on this shop. And I would need the wireless to connect to the camera, so I couldn't get it. I couldn't make it work for now. So at least for today, we'll see a lot tomorrow because we won't be able to machine all of these. Hey Beanie! Hey Shav! So, back in business. We are on the other shop. I'm sorry. Mess. Nothing I can do about it. It's the best I could do for now. So, just a little round about. So that back. There's the bench. Give me a second. Oh, we have sound. Test, test, test. Oh, wait, okay. I see. Give me a second. New setup. Yeah, it's the wrong... sorry. It's the wrong device. Yeah, okay. Device should be... right? Test. Nope, not this one. Okay, give me a second. Sound 1 2 1 2, okay. Not this one. So this is the camera. Motherfucker. Me. How can I solve? everything was fine earlier, but I connected an extra camera. Okay. Okay, I'm gonna do something else then. I'm gonna disconnect this from here, connect it here. And we should be fine now. So. No. Yeah, I know, because it's catching from a camera, but I don't want it from a camera. I put the default. Just form test one. Okay. Working there. Okay. Let me disconnect it. This guy. Technical difficulties, yeah. That's my middle name. Okay, 1 2 1 2. Okay, I guess we are fine now. Maybe I'm a little high on volume, not on drugs. I should. Okay, so yeah, looks fine. Okay, back in business. So CO2 laser there, big machine here, bench there, a lot of tools there, center bench, manual mill down there, and the blue guy. So should be fine. There's on the back there, there's my router, stopping arm over there, lathe back in here. So it should be good. Let me put this thing in here, maybe there. Okay, so we're gonna start. Let me see if my other cameras are working. So this one should be working fine. Let me, oops, why? Let me deactivate and activate. Why is it black? Properties. Oh, it's not detecting the... Why not? Oh, there we go. Okay, so you have a camera for the machine in there. And as usual, I think it's jumpy, right? Yeah, it's a little bit jumpy. So let's give it a nudge. So that's the best view I could get. I'm sorry if it's not good enough, but it is what it is. It is what I get. So we have here the
control of the machine, I set this camera so you guys can kind of see the control of the machine when I'm messing with it. Yeah, sorry. It's the best I could do in the time frame that I had. So it's jumping again. Well, it looks like the CNC is vibrating or something from such a heavy cut that we're gonna take. Behave. At least you cooperate with me. Okay, so sound problems are gone, right? Looks like it. So yeah, let's open the windows. I clean this window for you. I give it a protection coat on the inside, supposedly. Let's see if it's any good. We'll see. So waterfall better. So I'm gonna set up, we're gonna start with what? Let's see. Probably we're gonna start with the skirts, because it's the only big piece that I need to use both both vices. So probably, yeah, probably that's where we're gonna start. Oh, I need my tablet. So I use this guy for accessing. Let me clean all of this. Oh, actually I received a message. Oh shit, but I'm not connected to... I hope the internet behaves because I'm connected to the... this shitty hotspot on my shop, which is not the best, but usually works well enough for the shop. Okay, I'm connected. Why is it saying I'm not... Oh, okay. It was saying I don't have internet, and I was receiving notifications from stuff. Anyway, so... yeah, this thing doesn't like my gloves much. Need to grab... So yeah, I'm using gloves. I usually don't use gloves, but it's night, it's cold, and yeah. Okay, so I have access here to my network. I know you guys can see shit, but... and here is where I get the... where is it? Probably... Milo CNC. Okay, yeah, let's start... yeah, let's start with skirts. Okay, so I'm gonna try to show it here. So here I have access to the setup sheets that as we talk about. So it's a good. So since I'm not with Fusion open in here, this setup sheet will help me through the stock, through how to put it on a machine and whatsoever. That's why I lost the time doing the setup sheet. It's gonna tell me the tools that I need, even that I can see that in the controller as well. So I actually haven't set anything yet, so what we're gonna need? We're gonna need the face mill, which is there. There's no way I can show you. I think, yeah, there's pretty much no way. So I have a bunch of tools in here. Okay. So these are the tools that I will use in for the machining. So I'm gonna grab, I have the face mill there already. I have the chamfer mill in here. So we have tool 3, which is 8 millimeters, it's here. We have tool 5, which is end mill 6 is here. And we need a 5.2 millimeter drill. I don't have a 5.2 millimeter drill set, so we're gonna use a 5. At least I don't think so. Let me check. Pretty sure I only have 5. I don't have a 5.2 set. I could set it, but I don't feel like it. We're gonna have a bunch of holes with it, but doesn't really matter. I don't care. And I'm not feeling like setting a tool now. So we use a 5, which is this one. Should be fine. Everything should line up. And if we need, we can always enlarge it after on the bench drill. So the machine is warmed. I heated up a few minutes ago, so it should be good. So I'm gonna set the vices with the stock. So this is the stock for the hey Diogo. The stock for the skirts, 2 of them. Let me put one in here still. So yeah, let's start doing some stuff and stop chit-chatting. So I'm sorry I can't open this window more, but I can move the table a little bit to that side so you guys can see better. So these are modular vice. They will lock in on all these positions in here. So we just set it so they have some adjustment. Let me open it all. That one is fine. Oh, I need to remove it anyway. Okay, this one is locked. Shouldn't be. There we go. Okay, so we're gonna work on this range. So I'm gonna call it about here. So same for this one. You guys can hear me well in here because I am pretty much inside of the machine, and maybe you guys are grabbing the sound of the fans of the machine. Okay, yeah, so they are locked in place. So we should be good. I shouldn't need to mess with them more on the machining we need. Okay, let me grab my bed, my dirty cloth. Thanks for the feedback, Joseph. Let me do some cleanup in here. So yeah, the machine is way clean now, but after the first piece it won't be anymore. So in order to set the... Oh, another CG, yeah, we're gonna have some ships this time. Okay, so in order to set the stock in devices, we're gonna need some stuff we call parallels, which is this stuff. So these two bars, these are in sets, these are sold in sets, usually a bunch of different sizes, but always in pairs. Sorry, not sets, pairs. So they are exactly on the same height. So you can put one on one side and one on the other, and you know both are, well, both are parallel, which is, the name pretty much says everything, right? So in these guys I have two vices, so I need two sets or two pairs. And yes, I have two different sets of parallels. Actually I have more, but so I can set. So these parallels I'm using are 48 millimeters. The jaws of the vise are 50 millimeters height. Oh, slightly less than 50, like 49.9. So it means I'll have 2 millimeters of stock under, or grabbing 2 millimeters of stock. So I'm gonna eyeball it, so the gap on each side it's about the same. So now torque it down. I'm gonna torque it pretty well, because we only grabbing 2 millimeters of stock, so we don't want the parts to go fly. And you can see I can't move it. So now for setting up. So where's my tablet? There. So as you guys remember, when I first did the setup, so my origin, I'm not sure if it shows up, but my origin is there in the middle of the part, as I usually put it. So let's set up. I don't have on this machine, I don't use an automatic probe. I use this thingy, a Heimer. It's called a Heimer 3D taster, or 3D tester, I believe, since it's German. Pretty sure taster, it's tester. At least it sounds right. So this thing is 3D, so you can go one side, the other side, and the Z. So let me put it on the machine. Let me make sure the spindle is clean. Should be, but so I have this thingy. Oops. This thingy for cleaning the spindle. Yeah, the spindle is here on top. You guys are gonna see it well pretty soon. Actually, I can lift the camera a little bit, right? Since we are working a little on a higher side, yes, I can lift it like that. Okay, so now I just need to use my pendant. I need to activate it in here, so I'm first gonna set manual in here. Z's are blinking, which means it's the selected axis. And I can move it with this thingy. So here I can select the different axes, and here basically the scale of movement. So let's test Z first. Usually I do it on roughly the middle of the part. So I'm not sure if you guys can see on camera, but there are 2 pointers on this thingy. So the black one and the longer one, it's gonna mark the exact position and on the turn, and the red one basically it's the number of turns. Every turn it's a millimeter. I need to set the red on a 0 and the black on this 0 here, and the black one on there, so everything is set. So it's basically the 0 position. So see, we are at -1, we need to go to 0, so there, and then, so that's the 0 height, but I want to go deeper because I want, as you gotta remember, I usually set the 0 on the top of the part, and since I want to deck a little bit on the top, I'm gonna set it like 0.2 of a millimeter down, like that. Usually should be enough to clean out the top. Of course I could sweep to check for the low place and set it there, but there's no need. Usually if we need another pass, we're gonna give it another pass. So now I'm gonna set the Z0. So set coordinates Z0 and Z0 now. So now let's set the Y. So I want the center, so I'm going to measure both sides. So 0, here we want the actual 0 roughly. So set coordinates Y0, or Y, sorry, I'm speaking in Portuguese. So I'm going to lift it, I'm going to come to this side, and I'm going to measure the second side. So we are roughly there. So we have -72.2. Now I actually need to do math. So that means -36.1. It's the middle point. This one was easy. I have a calculator machine here on top that you guys can't see, that I can use. Nice. I like automated those cheap probes as well, especially because they are cheap, but I really like my Heimer, to be honest. And yes, you can automate this stuff. So let's set it at 0 there. Set coordinates X0. Let's lift it, go to the other side. This MPG thing, so this remote control, it's basically what it is. It's a remote control. It's awesome. I want to set one on my Milo as well. And I actually have an old wireless one that we can set there. So let's set it here. So X. I really don't like this controller that I can't actually do direct math on it. On Mac 3 I could just divide this by 2, just press divide by 2 and it would work. On this one doesn't work that way, and 345.4 we have 172.7. I could do it by head, but I'm sick, I'm tired, and that's why the calculator is for. Yes, MPG is a must. in my opinion. Okay, so we are set. So the first tool, according to, well, we can select the program. So program, USB disk, BMSP. So we should have a paste called Milo here. We are doing the skirts. So the back, it's the first one. Usually I name my programs like that, like 1001, 2001, 3001. The first one or the first digit, it's actually the setup number. So if I have multiple operations on the same setup, I'll call it like, let's say, if I had 2 operations or 3 operations on the first setup, I would call it 1001, 1002, 1003. Since we only have 1 on each setup, so, well, we have multiple operations, but not different files. So I call it like that. Why do I do it like that? Well, the default on Fusion for the name program it's 1001. So I just use that format. I'm not sure if it's visible on. I can set a camera only for the controller if you guys want. But usually this is only for checking. My preview window is very small. I'm used to having a big laptop, a big screen with a lot of stuff. So if you guys need me to show some detail on something, just let me know. Okay, so I'm gonna exec this one, and I'm gonna know my tool one. So on my post processor, at the beginning of the file, I spit all the tools that I'm going to use, as well as the Z minimum that we're going to be. So if I need to know if I'm going to hit a parallel or device, I can always check, oh, okay, so my tool 1, the minimum Z, it's going to be 0, so because it's only going to deck the top. My tool 5, which is a 6mm end mill, will go down to minus 15.1, so I can check that. My tool 3, which is the 8mm end mill, will go to minus 22, and if I feel the need to, oh, let me check if that thing's gonna grab the, device or something, I can always go grab my calipers and manual check, just do a sanity. Okay, so I have 23.26, should be fine since we only eating 22. Now the tool 10, it's going to go down to 24mm, 24.5, but that's a drill and that's in the middle of the stock. And since the stock it's actually 25mm, we won't even hit the so it's actually 25.2. So we won't hit the parallels anyway, so it would be a good call to remove the parallels under it, but we're not going to get there, so there's no need. So yeah, so I have the machine set for manual tool changes, so that's fine. So I'm going to set it to auto. And let's go, program start. On my manual process, the machine will go all the way up. It's going to ask me for tool 1, it's here in purple. Insert tool 1 and press cycle start. So I'm going to insert tool 1. Close the windows. And let's go. So since this is the first time I'm running this program, and especially in live, that's why I really like to have this complex panel. So this is the feed knob, so I'm gonna move the feed back to the lowest setting, which is 10%. This is the spindle RPM override, so we're gonna keep that at 100, and these 2 buttons will control the G0, which is the rapids, and I'm gonna set those way down to 5%, which is the minimum. And I'm always having my hand in here in case of fuck. Yeah, I forgot something. Give me a second. Let me pause. Yeah, I was cleaning. Yeah, I fucked up really bad. Ah, fuck. I need to turn on the O's that on the back, so give me a minute. Yeah, the access is awful. Bear with me just 2 minutes. Because I was cleaning the machine and I forgot I need to switch the hose position to clean the machine. Just a minute. We should be set. Let me untangle this. Yeah, it should be set. Where is my plug? It's here. Oh, since I'm there, give me a second so I can do something else. I can do something else before we start, because it's gonna get in the way anyway, so. Better do it now. There we go. We are done. Okay. So let's restart. Auto. Okay. So it's gonna weigh all the way there. It's gonna turn on the coolant. There we go. So it's gonna start out. And there we go. Okay, so the material is very bent. So I'm gonna need to lower it a little bit more. It's not grabbing the whole stock. Actually should be okay, but yeah, I need to go down a little more. It's normal on such a big piece of stock that it's not flat at all. So, not sure if you guys can see, but I'll show it in a minute. So I'm gonna stop this manual. So here, this section, it doesn't reach, and a piece of on this corner as well. So I'm going to lower a 10th millimeter more. So 50, show coordinate 54. So I'm going to set the Z. So we are 63.9. We want to take 1/10 more. So we need to add 0.1 in here, which is 224. Call it even. And let's go again. Yeah, there we go. Yeah, first chips for Milo. So the behavior on this window is clearly different from this one. Not sure which one is better though. This one is runny, this one is spotty. When it grabs more, it runs down really quick, way more than that one. These gloves are small for my hand. How is the noise? Is too much noise? Or is the noise cancellation doing... Well, I still have the corners there. Not sure. Let me check. I'm pretty sure they're gonna go away. Let me check the setup sheet. Yeah, they will go away. So I still have material on these corners. I'm not sure if you're showing or if I'm showing on camera. So I still have a little bit on there. But since the part is like that, so those corners gonna go away anyway. So we're gonna leave it, should be fine. So next tool is tool number 5, which is the tool, the 5mm, the 6mm mill. I like to clean the cones. So let's see if everything goes fine. Again, reducing everything to the minimum. Thing looks fine. Let's increase speed. So this is just the counter bores for the oh, actually it's the okay, actually it's the pockets for, well, for making it lighter and kind of more beautiful, prettier. I thought it would be only the counterbores for the screw holes. Oh yeah, that's it. Yes, yes, you're right, because this part is the back. Yeah, you're right, you're right. We're starting with the back. Someone is paying attention. Okay, now the noise filter is catching everything. It's much more noisier now. So now it's finishing the floor. First it did the roughing operation, just removing material. Now it's finishing the floor. Not sure about the walls, I'm pretty sure I'm gonna leave the walls to last. Well, I need to trust my work. Okay, now it's gonna finish the walls. In a production environment, you would do by area, so the machine wouldn't be messing around to which side. You would organize the machining by areas, but this is not production. So let's give it a little. Okay, so we have I'm not sure if you guys can see anything, but we have the pocket profiles. Maybe I should lift the camera more, so instead of such a shallower. angle. Let me do a sanity check and make sure. Oh yeah, we are on. We are on. Hey Kegel! Okay, so now we're gonna do tool 3, which is the 8mm one. So now it will machine the outside. 8mm, it's my most used mill by far. It's my go-to. So I'm gonna reduce everything again. Make sure nothing stupid happens. Everything looks good. Let's give it power. I'm hogging a little more than I would like. Spindle is kinda slowing down a little bit, but a little rougher. Probably the end mill needs a replacement, but should be fine. Spindle is dropping a little bit. Now we have ships flying. Now we should do the finish. It was this was a 2D adaptive. Now it's doing the 2D contour. So a 2D counter is just moving around the part once or moving along a path on the part, moving along a profile. And the 2D adaptive, it's gonna take the profile that you need and it's gonna like take cuts until it reaches the profile that you need. So we have a close to shape of what we need. So what now? Now is tool 2, it's tool number 2, which is the chamfer or spot tool. Fine. Again, let's go slow to start because shit happens. Okay, it's doing some spotting. Yeah, it's spotting the holes we have on the I have a problem, or not a problem, a defect, let's call it like that, on my post processor on the drilling toolpath. I need to fix, but I keep forgetting. I only remember when I'm machining. A little shattering, but it's a long tool. Now just an air on the outside. And then we should have the drill, which should be the last one. Speaking of drill, I need to grab my notebook. Okay, since I use a bunch of drills, of different drills on this machine, so I don't have all the drills set on the actual machine. So the way I work is I usually use tool 10 and then tool 90 to tool 99 for drills, and then I fill them out according with the drills that I need. In this case we need the tool 10 to be 5 millimeters, so I have the offset in here for the 5 millimeter drill. It's minus 51.45. So I go here to the tools on the machine. We're gonna need tool 10, so I'm gonna clear the tool 10, and I'm gonna put the minus 51.45, which is the length of this specific tool. So tool 10, 51.45 negative. So now the machine knows that the tool I'm inserting is the right tool that we need. But since Bruno sometimes fucks up, let's go slow anyway. So sanity check when the tool is roughly at the stock top, which actually is a little lower. I'm gonna check in here, and Z it's at about 0, so it match up with what I'm seeing there. So we can turn on the coolant and move on with the drilling procedures. Could I go just straight down? I could, but since this is a HSS drill, I prefer to just step it down. Doesn't hurt. Gonna take a couple more minutes to drill, but it's fine. If it would be a good carbide drill, I would go straight down, full power, no worries. And we should be fine. So on the last operation, when the machine ends, it's gonna bring the table up to the front. Okay, so it looks close at least to what we need, and since we are machining two of these parts exactly the same and the stock is exactly the same, so let's just use the same setup and make the second one. So what I'm gonna do, I'm gonna grab a magnet. Actually, I have one in here. I'm gonna clean it because it's full of metal dust from the shop. Best way to clean it, it's with compressed air. So this is something I used to do, so I'm gonna set it down here, touching that corner. So I'm gonna remove that piece and put the other piece. The first setup doesn't really matter if it shifts a little bit, as long as we have material to cut, we should be fine. Looks good, shiny. So let me put it aside. Let me make sure we don't have ships on top of the parallels. Make sure that one doesn't move. Let's grab the second piece. Let me give it a pass here on a polisher. Just to remove some big shapes, big burrs. I deburred all the stock before the stream. There. Good. Now don't forget to remove the magnet, very important. Change tool. So we're gonna go back for the face mill. And let's go. We just run the program, everything is fine, but I really like to start slow. Make sure everything is fine. Well, the magnet, these are strong magnets, they don't move that easily. They can move, but even if they move slightly, this is the first operation. We have plenty of stock around it to, unless it moves more than a millimeter, which is kinda not usual. Since the magnet and the vise are pure steel, the magnet holds very nice enough, let's call it that way. I usually don't use that technique for precision when we need precision positioning, but for the first operation it should be fine. As long as you take care and you really check that it doesn't move, it won't move that easy. So this one looks even worse than the other one, I think. Oh no, no, it's fine, it's about the same. I have a little bit on the corners, but those corners are gonna go out anyway. So we are good. We are good to go. So tool 5, right? Yes, so it's 6mm hand mill. Yeah, because this thing is scary, going very fast into the material. Okay, so maybe I'll try to lift the camera more. Yeah, I think it's better. Oops. Wasn't intentional. Can it focus there? It's better, right? fuck? Oh yes, you might be right. Let me... Should be better now, right? It will zoom out in a minute or in a few seconds. There we go. Hey, well, Adama, so we are machining the skirts for the Milo. Fuck, now I can't open the window. Guess I'll need to deal with the wire, the cable. Okay, fine. Now should be the tool 3, which is 8 millimeters, 8 millimeter end mill. Yeah, I need to figure this out. Okay, so move. What can I do? I can't do anything. Just leave it. Now finish operation. First we did adaptive clearing. Now it's finishing. I'm concerned this piece of stock was a little smaller. Yeah, I think he cleaned it. I don't really care, because this part is for me, but yeah, it didn't. Doesn't matter. It's fine. It's gonna be on the back. No one will never know. Tool 2. What I can give it a little nudge by end. Just a cleanup passage. Okay, this camera is here. Tool number 2, which is the chamfer. Tool, go. Yeah, let's go. Well, I know what I can do. You guys are gonna drop feet for a second. Shit, I really hope that piece won't bite me in the ass. It probably will. It probably will. It's still a bit, it's like half a millimeter. We'll see. Should have done a check first. Anyway. Doesn't matter. So now tool 10, which is the drill. And this time we don't need to set the tool because it's already set. It's only now every time I call tool 10, it knows it's that tool as long as I don't need, every time the tool 10 is the 5mm drill, I don't need to change it anymore, and supposedly should be until the end of the everything is machined. Okay, so since I fucked up the initial positioning, and no, it wasn't the magnet that moved, it was the stock was smaller than the other one. I should have, to use this technique, I should have first checked which one was the smallest. I thought they were equal, to be honest, and they weren't. See, if this was for a customer, I would need to make a new one, but it's for me, it's fine. So it's just this corner here. It's not, yeah, because here we cut like 1mm, and here it didn't reach. So I'm gonna fix it by manually. So I'm gonna put the tool 3. And I'm gonna go to EMDI G43 tool 3 H3. So this is gonna load the tool 3 in the machine. I'm gonna go on the end wheel. Actually, let me. So the part is 343. 343 should be 171.5. So 343 divided by 2, 171.5, plus 4mm on the tool. So it should be 5.5. Let me make it like that. I'm gonna go down to 22mm, which is the cut that we are making. So 20. Make sure everything matches as it should. Yeah, we should be fine. We settle 21. And let me start the spindle. S8000, that's fine. Clockwise. So 22. It shouldn't do anything. So let's do 1/10 more. Or actually maybe 2/10 more. Nothing. 4/10. Fuck. There we go. And we don't need coolant for that. Let's check. So we are 6/10. We need more. Now I'm gonna turn on the coolant. I'm gonna give it one more. And we are good. So we have a part which is 7/10 of a millimeter smaller. If you guys don't tell anyone, I also won't tell. Should be fine. We're gonna set it to the back. Hello, Pedro. Welcome. So now, yeah, let me clean all of this. Let me move this thing up and away. Let me move this thing that way. That's fine for now. Yeah. Oh yeah, some CNC working. Okay, so let me move this thing here. Let me remove the tool before any accidents happen. We are done there. Before I forget, let me insert tool 0. So 0, 0, done. Okay, so let me clean it. Yeah, I could have removed a little bit more. No, it's fine, it's fine, it's fine. It's perfectly clean. Was just a finger smudge. Good. Except that piece, but we're good. No one knows. No one's seen anything. There's no video proof of anything. So we are good. You are good. Anyway. Hey Bob! Okay, so let me grab my tablet. So let's check the second setup. So actually let me close a few other setups that I have in here. Okay, so third front. Third front, of course. Yes, of course. It would have to mess with my thingy. So let's not forget we took a chunk of 0.7 millimeters on that thingy. Yeah. $17, that's 7, 6, yeah, should be fine. Okay, let me clean. So this is my separate set. Let me put it aside. Have it off. Yeah, that's fine. That's fine. It can be in here. We're gonna need them again, so no point on cleaning them too much. So I'm gonna use a different height now, so we can grab a little more. Let me zoom out. Camera is moving, right? Okay, so I'm gonna set some 40 millimeters. Oh, 34, that's 34. Nah, I need higher ones. 34, 16. It should be fine. So let me load my program here. So we have 17, 8, no, 13. Nah, I need smaller ones. Let me grab a bigger one, sorry. It should be fine. 13 probably it's in the middle, but anyway. Let me grab my 40s. 40s are good. Yep. This camera, since it fell away, I guess it liked the feeling, so sometimes it needs some knock knock. Make sure there are no ships under the parallels. Kinda defeats the purpose of the parallels if ships are under the parallels. Okay, let me grab another set of 40s. There we go. Okay, so before we start, well, it doesn't really matter because in this case we have access to the height of the parallels on the sides. But let's say we were machining a piece that was bigger. So now would be the time to actually you could measure the height, since I'm gonna locate the work on the bottom, but since we have access to it, it's fine. So on my setup sheet, so I call it like that, so the chamfers are to the front, oddly enough, so it's like this. So basically I'm gonna need that corner there. And since this one, it's the piece that I'm missing 0.7, I need to take that into consideration. So let's do the job. Hey, just push print. Just push print. Welcome. We are doing some just push cut. Okay, so no need for many force. Now, since we have a straight face, I'm gonna actually tap the whole thingy in order to make sure it's touching the parallels. They are. Now we get the probe. And we start probing. Let's let's exact this one, manual and wheel. It's not quite centered, but it's fine. Okay, so we are looking for this corner here on the bottom. So let's go down, 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 down we go. So I'm going to push it on the probe on the parallel because it's the floor that we want. There we go. So let's set Z0. Now we are looking on the front corner, so we can push the jaw of the vise for Y. So let's go up. Let's move it closer to the piece. I need to go a little lower. And we're gonna set it on the jaw there. Actually, I'm gonna compare it. There's a possibility of the jaw being flexing a little bit, but it's gonna be fine for this operation. For this piece, doesn't really matter. So set coordinates Y0. But we can check the difference actually. So I'm gonna use, this is what I would use for a regular high precision job. So this is a cute 123 block, but it's like a 10, 20, 40 metric in millimeters, of course. So I know it's 10 very accurately. That's 10 by 20 by 40. So I could go in here, close the Z. I could set the, let's call it the 20 face. I could set it here on the machined surface and press it here. And see, we have something like 1/100th of a millimeter difference. So yeah, literally 1/100th of a millimeter difference from the the jaw to the actual workpiece. So I'm not gonna mess with that. I'm fine with that. So now there's two ways, since we decked this part. So this part is actually fake, since we manually milled it to make it prettier. So we could measure on this side and call it the full size of the part, or we can measure this one, and since we know we cut 0.7 millimeters off, should be fine. So the easier way would be, let's say we didn't knew how much we cut on that one. So we would go to this side, and with the same technique, yeah, close, very close enough. So we know the part. Fuck. Okay, so we know the part is 343, but we have 20 more millimeters for the block, so it's 363. So let's call X 363 millimeters. I think it's 343. Let me confirm. See you later, Beanie. Or see you tomorrow, actually. Yeah, so according with my setup sheet, the part is 343. So 363 is fine. Let me remove the block. Let me move this thing up. Remove it. And let's load. It's loaded already. So let's load tool 1, which is the face mill. And let's rock it. So we should remove a few millimeters on top. Not sure exactly how many, because I don't remember. So the part is 23 millimeters, so it should be about 2 millimeters. Now Beanie is probably going to sleep. What time is it? 23:23. Yeah, let's speed this thing a little bit. Don't worry about the noise, it's just though that flat piece of aluminum that's from the corners, which is very thin. It's gonna do way more on the next one. Because it lacks support. It sounds like a sci-fi movie. A little bit. Now it's an horror movie. It's fine. Let me decrease the feed for the finish pass. It's gonna be there like 1 millimeter, which will only be removed when we do the chamfering. Actually, we're gonna need the big chamfer. Let me grab it. I don't use this tool very often. Well, maybe it will be removed by Portuguese persistence, but no, it didn't. A little more shattering. There we go. So now we're gonna add some 8mm to make counter bores and the side and the front pockets. Where is the cross? It's there. So 8mm. So these are just aesthetics. Yes, it has inserts on it. So it has those TP are inserts. Where is the... Oh, it's for the counter boards. Yep. On these ones we have two... So on these ones we have two cutting sides. So we have the top and the one on the bottom. This one I think I rotated them, I'm not sure, I will need to check. But yeah, you get two cuts on each of these. Some you have 3, some you have 4, some you have 8. Depends on the blades or the inserts. Not really on how many edges it has, but actually some you can actually flip them, and they have on the front and the back, so it doubles the actual edges. I forgot to reduce the speed on this one. For finish speed. Oops. Hey Simo! Yes, I'm machining today. Making shapes. How are you, Martin? Okay, I should take notes. Oh, you're way too fast. Go slow, my friend. Okay, let me grab my notebook because I need to drop these feeds. Yeah, can be in here. Let me grab a pen. So this is the skirts. Front. T3 finish feeds. Needs to be fixed. Yeah, it's good enough. Yep, it'll be fine. Ah, damn camera. Oops. On. Okay, so next one it's the 225, which is the big chamfer. Let's go. Nice and slowly. Everything looks good. Hyundai has some nice machines. Hyundai, brother. Yep, it's doing some chamfering. Yep. Well, it depends. Now everything uses everything. I've seen DMGs with Fanuc, DMGs with Eidenheim. Now Siemens, it's much on it's a trend. The Siemens controllers are very nice. There goes a little bit. ET just died. Well, that was the ET sister dying. I hope we get a nice kit from this. At least so I would like to sell a few, just at least to pay for the time that I spent on it. We'll see. It's gonna be a fun project. Hey Jack, how are you? So now I believe it's doing a finish pass since it's a very big chamfer to do all at once. It doesn't look bad from here, but yep, it's definitely doing a finish pass. Yeah, me too. I'm with the flu. I hate the fucking flu. And it's the early stages, so it's gonna be a while until I get full power again. So right now we are machining the skirts for Milo. I'll leave it like that. Yeah. Every fucking virus is not good at all. I think it's, oh no, I think it's still missing the center, right? Yeah. I could be working a little faster, to be honest. It's fine, we have time. So I think it's the last, yeah, it should be the last operation of this side. So looks nice, shiny, definitely shiny. Okay, so same story, let's grab the other one, and now we only need to set the X. Making sure there's no ships under on the barrels or the jaws. Yes, it is. I like it too. So let's tap it, tap it. That's good, good, good. Fine. Fine. So now we need to measure only the X. All the others are fine. Same Z. Same Y. Just need to settle the X. Okay, let's finish. Manual. So we're going to use the same trick again. So I'm using the 20mm gauge. So when we are on, we know that we are at -20 because we are on the negative side 20mm, and we should be good. So let me remove the gauge. Move this thing up. Yeah, that's the harder part. Well, especially doing them well. So first we need the face mill. We're gonna repeat everything. So auto go. Let's yellow it. As usually, I'm gonna start slow because sometimes Bruno makes stupid shit. There we go. Let's go full blast. Hey, Luis. So shit, now I don't have the part. So the part has a step. Okay, so the part we were decking the top, and we needed to measure. So it had a little bit running out on the top for all the sides, and we needed to reference this edge that is machined already. So since we had a little bit on the top, the probe couldn't reach the machined side of the part. So we needed to use something precise to offset the machine side to outside of the stock. So imagine that this piece is the stock leaving. Where is it's on this side? See? So it's imagine it's like that. So there's no way to reach with the probe on this side with this one on the way. So basically with the gauge we offset it 20 millimeters to the side, and then we could measure it. Yeah, okay. We talked about this when, as Joseph said, when we did the cam part of this, we talked about this specific subject. In the stream, but yeah, I'm glad you asked, because that means someone at least is paying attention, and it means I can teach something new to someone new. It's just a little trick that sometimes we need to use. Well, thank you for that. Just print push. Just push print. Just print push. That's funny. That's the whole idea of me making videos, is to actually teach someone something new. So I appreciate that. So what time is it? Yeah, we're gonna do 1 more hour of machining or so. 1.5 hours, and then I'm gonna get some rest. Tomorrow I'm thinking maybe I'll do a stream after lunch, and then the other one after dinner. So we can, I really don't want to have the cameras here on the main shop. So I want to get rid of this stuff as fast as possible. The Cav is designing, Cam is programming the machine. So CAD means computer aided design, and CAM means computer aided machining. So the part of CAM is actually programming the machine for doing the cuts. 40% should be fine. Oh, actually, okay, I can't go fast yet. I thought it was finishing already. Okay. Yeah, okay. So I'm overriding the feed because I forgot to slow down the stuff for doing the finishing, and since this one is the front one, I'm gonna slow it down to see if it's a little better finish. It's not that the other one is bad. It's not that the other one is bad, but it should be better like that. It's actually not bad at all. For the speed it was made, it's not bad at all. Hey, questionable. What did I miss? I missed nothing. I missed nothing so far today. Even that one small mistake that supposedly I did, there's no proof at all that I did, and I fixed it. There's no video proof, no one saw anything, so it's all fine. So now it should be finishing the floor. There's an extra pass to finish the actual walls of the pockets. So that's the last pocket. Now it should be finishing the walls. Yep. So now he's doing the counterbores for the screws. No frames dropped. Okay. Looks like the laptop is going on fine. Okay, now the big chamfer. I know it's fine, it's just an habit. I think this is the only... No, actually we have the spindle mounts also to make two of each. Other than that, this is the only part that is repeated. Well, there are another one, but we're gonna make them all at once, so it doesn't count. So It's different. You see a lot more vertical mill, vertical machining centers than horizontal ones. Either of them are good. I think horizontal are better because you have gravity, so ships always fall down from the part that you are machining, but usually they take a lot more space. They are more difficult to build, and yeah, that's why they are more expensive and they are better. It's not better, but yeah, it's better. I think they are better. You don't see a lot of horizontal mills just 3 axes. Usually they are at least 4 axes. So we should be finishing soon. I think this is the last pass, if I remember correctly. Well, yeah, I think they are better, to be honest. And you don't see them that usual, but they are way more expensive, that's for sure, because again they are harder to build, but you have gravity helping, which helps a lot, to be honest. And but yeah, it is what it is. No, it's the same. Usually, when you have an horizontal, it's the same thing. But usually, when you have the horizontal machine, usually you work with a 4 axis, which is probably it will mess all the angles. I believe it doesn't matter. So you basically use a turret, you have a rotating axis on the base, and you have the spindle like that moves like that, and probably like that, or maybe the table moves like that, and the spindle just moves up and down. And when you have a rotating table, you get the thing, usually people on horizontal ones mount what we call a tombstone, which is like a vertical pillar, which is indexed, usually 4 sides, but you can get, depending on the size of the machine, whatever. And then you can have multiple vices mounted on each side of the tombstone, and then you just index it, and you can have several vices, like I have on my machine, like 2 vices or 3 or 10, depends on the size, but usually that's how the horizontal big machines work, like that. So they put a tombstone on the thing, and then you just rotate, and every time you rotate you gain access to actually the sides of the pieces that you put on the vise. So it's like a 5-axis machine. What is a 2026 project? A horizontal mill? Nah. I don't have the space for it. And actually when I built this one, I thought of building an horizontal one. Anyway, so we are done. Here, let me zoom out. Okay, let me move stuff around so I don't get full of ships. First, now let me move it first. Okay, so we have another beautiful part. See you, Pedro. Thank you. And welcome. Everything looks good. Let me see if I spot any difference on the finish. Yeah, it's barely. Yeah, barely. So I don't even see if there's a need to slow it down. I can't see any difference. Well, yeah, I can't see any difference on the fast one and the slower one, so probably let's leave it faster, right? Okay, so now next setup. This is why I like to do the setup sheets, because I can have everything on my tablet. Okay, so it's the front to the vise, and yeah, it's front to the vise and the corners up, of course, because it's the top. Nah, I'm gonna leave them raw. So next setup, it's gonna be like that. So the origin, it's in here, this corner. So we're gonna need to close our vices. I could anodize them. But it's gonna... Yeah, we'll see. You guys want me to anodize them? No, I'm not gonna release the the machining files, the parts that I designed. You guys seen me designing. I showed everything on stream designing them. So if you want to design them, feel free. You can check all the dimensions. I done everything on stream. I'm gonna sell kits, but I'm not gonna provide the files for machining. Oh, I don't know how to hydro drip. Would be funny. Well, anodize, it's a fucking pain to do. It's a lot of boring. It's not exactly cheap. I have all the equipment. I do anodization as well. I wasn't thinking about anodizing these, but if you guys want me to, I can't say no. Nah, copper plated, absolutely not. Absolutely not. Not copper. Copper, it's even worse than aluminum. I mean, for oxidation. I either anodize them or I don't do anything to them. That's the two options. Either raw or... Yeah, I like the aluminum, and that was the plan. But I don't know. We can anodize them. I'm fine with that. It's just extra work and extra cost because the anodizing dye, it's not cheap. But yeah, we are talking about, I don't know, 10 euros of pigment for all the parts. We'll see. Maybe I'll do a poll on Discord. And anodize or not anodize? For anodization, it will take me like at least 3 runs to be able to do all, well, maybe not. I need to do some math. Yeah, probably 3 runs to do them all. Can I close this thing all the way? No, I need to close the vise. Let's do that. Oh, we are still paralleling here. Yeah, first, if we're gonna anodize, we first need to check if everything fits properly. So I'm pretty sure it will, but we never know. We only need to test fit. Doesn't need to assemble everything. I hate fucking shit. Let's go there. Should be fine. That's fine. So 5, 5. Sure, just push print. Feel free, man. See you later and take care. Okay, so now what? Now we need two parallels. Not so big, not so small. Let's call it for 24s. Should be fine. Yeah, 24s. So I'm gonna use one on each vise. Oops. Sorry. So I put one parallel on each vise because we don't need as much, since we're gonna run the parts on the vertical. Like that. Ah, fuck me. Let me make sure. Let me make sure the vise jaws are clean on the back. Yeah, clean. Like that. Fine. No need for too much force. And I'm gonna actually remove the thingies from the bottom. Let me give it a little more. Yeah, that's fine. Some more agadagas. And we should be fine. So now it's the top front corner. So everything, we can reach everything with the probe. No need for fancy tricks on this thingy. What time is it? Would like to machine some more stuff. Getting what am I missing? Here and here. Okay, so we have the front top corner. When I say the front, it's the front of the part, so the back of the machine. So we're gonna start with X. So hopefully we can reach X. Down there. Yeah, that's fine. Yeah. Everything is fine, so we can reach it. 0, like that. Set coordinates X 0. The Z, I like to put it on the middle of the part. Doesn't really matter on this specific part. There. Or set coordinates Z0. And now the Y. We need to be careful because we have a chamfer and we have holes, so we want to avoid all of those. And yes, we could use the front of the jaw of the vise as we used before, but we have good access in here, so that's fine. And we are pretty much dead on. We are 9 microns, so I'm not gonna even bother messing with that. So it means everything is aligned. Since the last setup, or all the setups. So if I remember correctly, we need a new tool. Exact. So yeah, we need T7, which is a long 8mm mill. We need T6, T2, sorry, and T10 again. Okay, so we only need the T7, which is new, which is this little girl. It's just a long reach. Probably the other one would be fine, since we are machining on the corners, not really on the top of the machine, of the part, but we never know. I'm gonna go slowly on this one. Yeah, okay, go. And go fast now. Make sure I don't fuck up again. There we go. Yeah, everything looks good. So this part I actually changed it, I believe, off stream, because we were supposed to be machining from the bottom and just drilling and putting some threads for fit. But since we are doing casa and we actually need to attach the skirts to the enclosure on these holes, so I needed to change that and do counter bores so we can actually install bolts down there and fix the machine to the enclosure. So it was a last minute kind of change. Now just spotting. Let me do slowly again because it's deep and I really don't like. Should be fine, but yeah, should be fine. This is why I like these quick access knobs and buttons and whatsoever. I can adjust everything on the fly without you need to look to the touch screens or whatsoever. So that's why I really want a nice panel on Milo to do the same stuff. No, I don't mean everything I have here, but most of the stuff like coolant button, spindle, CCW, CW, quick feed rate, override, spindle speed can be buttons, doesn't need a potentiometer or a multi-position switch like this. But it's definitely something that I want, is some physical buttons and LEDs displaying what's on, what's off on Milo. I got used to this and I absolutely love it. So I don't want a step back. I want a step forward. Okay, so let's go with a 5mm needle now. Drill. So it's T10, right? Yes, T10. So it should be all good. We used it a bunch already. Yeah, we are good. Yeah, fine. Okay. So I'm gonna do some, well, first let me check something. So where is the mistake we fucked up before? Okay, so it's on the other side. So I'm gonna do the same shitting that I did before. I'm gonna put in the parallels again. Why are you not getting? There we go. That's fine. You see there. And I'm going to use the magnet again, because this doesn't need to be absolutely 100%, and I can leave actually the parallels. They are not in the way of the holes. Sorry, this is in the way. Everything looks good. I'll use a deburr tool to chamfer this in a minute. Let me blow away the coolant and chips and whatsoever. Make sure the magnet doesn't move. It's kind of important. It's a strong magnet, so it takes a bit to... Good night, XF! I'm gonna be... What time is it? Yeah, a little more. Choose something small to do next. Okay, so I'm gonna put away from the magnet. I'm gonna grab the magnet, I'm gonna touch the part like that, and we should be fine. Like that. And since I can leave the parallels because the holes are not gonna interfere with it, I'm gonna leave them there. This magnet trick, it's good. You just need to make sure you use good magnets, strong ones. So again, let's go with the this girl. Everything should be set. We don't need to do anything except press go. And since I'm a pussy, I'm gonna go always slow at first and walk it in. I need to go a little slower on this guy. Yep, I saw that, XF. I saw that already. It's on my list. Okay, so now tool 2. Which is the spot. It was me. Because I don't like to see that thing moving so fast without being sure it's gonna stop. So far only once I fucked up that way, but it was scary. Fucking floor trembled with a fucking impact. Nothing moved, nothing broke except the drill. But it was scary as fuck. Definitely don't want to do it again. These are not NEMA 14 or NEMA 17 pushing the mill down. Not even NEMA 23s or 34s for that matter. Fine. Remove. Okay, there we go. We don't need our positioning anymore. And we have our top drills for M5 screws. Okay, so let's see what we get next on, or what we get first on the list. So last, machining nuts. That sounds fun. Let's do that. How many setups to? Oh, 4 setups. Okay. So you have to machine everywhere. Sounds fun. Let's do them. And let's finish with that. Okay, so let's use this vise. Let me see if... Where is my... Fuck. Yeah, I'm pretty sure it will fit. Let's remove the magnet and the parallel. Yeah, I'm gonna assemble on that one, so we are good. Remove the magnet, go in here. So let's grab our big parallels again. Make sure the floor is clean. Like that. Let me grab the piece of stock. It's a little rough here. Let me pass the corners. Okay. Oh yeah, we are good. Fine. So let's proper torque it. Some good dagger-daggers there. So I'm not gonna reach the setup sheet because I know that my first cut, it's always on the middle of the stock. Unless I'm doing a big production, something that I know I need like at least 10 pieces, then I'll do the corner so I can save one setup, and I'll set the stop, the vice stop, so I can just keep setting new stock material roughly on the same position. Okay, so let's start with Z. Let's go a little under 0 so I can deck the first. Let's do Y now. So 0. I could measure it with the calipers and do the set the size immediately, but that's fine. So we have 38.4 minus, so minus 19.2. Set X 0. And X 159.2. We have 79.6. Enter. Manual. Okay. If I remember correctly, on this one we are not going to use the face wheel, but we'll see. Yeah, so we are going to use the tool number 3, which is the 8mm mill. Let me check. We should be 19. We're gonna go as low as 17.2, so we are good to go. Auto go. We did well on starting with those parts because these parts need some accurate Machining. Machine is warm already. Something is not right. Let me stop it. Manual. Manual. Okay. $159. Have I grabbed the wrong stock? Let me check. Have I cut the machining nuts front? Oh. Okay. So I actually okay, that's right, that's right. Yeah. I'm sorry. So it's actually my mistake, because the stock is too big. Yeah, the stock is too big for this part. I don't know where I got this number from, and it's this one, right? 38. Yeah, it's 38. But it's 140, and that thing has more than 150. Okay, so let me cut a piece. It's fine. It's fine. Just I need... It would be a problem if I needed a big piece and it's a small piece in there, but since I need a smaller piece, I can easily make it smaller. Where's my ruler? And my pencil. It's easy to make a small piece from a big piece. The other way around, not so easy. So we need about 140. So let me go to the saw, which is back there, and fix this problem real quick. Problem fixed. Let me just deburr. We are back in business. Okay, we need to remeasure the X. But this time we're gonna do it a little faster. So we are 7.2. 70.2. What's going on, Simon? Haha, fuck! I forgot to push the mute button. Sorry about that. So I need to set X. No, Ash. Set X to 70.2. Yeah, the saw. Sorry about that. Completely forgot. Okay, we should be fine now. It was actually I didn't forget. It was to check whatever was still in here complaining. And I guess at least one person is. So let's go again. Go. I did. Yeah, now it looks good. There we go. Let's go full blast. Making chips. Well, while the machine is moving, I'm gonna actually drop the speed a little bit. I need to grab some stuff to test in here. So while he's cutting, give me a minute while I'll get the stuff. I'm back. I'm back. Ellie, thank you. Okay, since I'm here, let's full speed up. I think for this, yeah, it's set. Okay, so it's doing the facing. We are doing the facing on this one with a mill because we're gonna need some precise stepping. And this way, since we are machining with the same mill, there's no tool change variations or whatsoever. Even that this machine is very precise with the tool changing. Same tool, it's always the same tool. It should be doing next yeah, the stepping that I was saying. So this is for the preload nuts, washers or springs. Okay. It cleaned everything. So we are good. Let me grab a washer to see if it fits in there. It's supposed to be a close fit, but not that close. Let me check. Yep, we have about 1/10 of a millimeter of play, which is what we aim for. So we are good. There's no way I can check for the... well, I can measure it. Yeah, we have 22.1, which is perfect. The ball nuts are 22 spot on, or even a few cents under, so we are good. We have about 1/10 of a millimeter gap, which is fine. What next? Tool. Chamfering. Let's do some chamfering. Probably some spotting as well. Actually, some spotting to start with. Yeah, that's fine. There we go. Everything looks good. So now it's chamfering. First was spotting. Should be just cutting the edge there. Yeah, I can barely see it. Probably it's all around. Just cutting the edge, so it's not a sharp edge. I don't have. To be honest, I only use it like a few times, and I didn't have the time to load all the tools in there and set everything up. I'm not doing a production work, so many times I use much more tools that I can hold on the ATC. So I just regularly I don't use it. And honestly, I think one of the valves is actually faulty now. I think, I'm not sure. Not sure. Oh, so we have a new tool that I forgot. Okay. Actually, it's a little more and I suck, but it's fine. Okay, so we have the 3.7. 3.7. Let me grab the 3.7 drill. So 3.7, is it this one? Not sure, need to check. Don't think so. No, this is the 3.3. That one it's not for sure. That one it's not that one. It's this one. It's this one. I'm swapping tools all the time. Okay, I need to set it. So it's tool 91. So we need to go to redeem, which is my tool list. I don't know why they call it the redeem, but okay. Tool 91, which is here. And we need to set it to 3.7 drill, 3.7, so minus 30, 67. Clear, minus 30, 67. Yep, so T91, 30, 67 negative, fine. And if I didn't fuck up, it should be good to go. So we are very close, we are very close, we are good. Oh, actually it's a step drill. I thought it would be a all the way drill. So that means we're gonna need the 4mm top. So let me grab that. 4mm form top. What time is it? think this part is the longest, the front one. Okay, so now we need to check the T12. Actually, I think I have a T12 in here. Let me save this T12 value because I don't remember. What's the value? 42.89 minus 42.89. I'm gonna clear it, and I need to change it to M4 top forming top 232 minus 232 minus 2.32. Okay. So let's do some tapping. This is the fun part. So let me grab my oil. And down we go. Let's go slowly, make sure everything is fine. Yeah, and this one will be, oh, okay. I stopped, I want to do some zooming there. This stuff is fun. Let me just make sure everything sounds right. So we are about 5 millimeter. 5 millimeter should be all good. There we go. Cool stuff. Goddamn camera. Okay, I think we should be fine on Yeah, on this side. Jesus. Hey, Bill. What's up? Doing some sheeps today. Okay, so next side should be the top. So let's go to that. Looks good. Shiny. So the top is this side. Sorry. Let me zoom out. Oops. Yeah, like that. Yeah, it's not a bad day. Should be out in a minute. There we go. Okay, so there's not much to mess around. So if it's the top, I'm always put the machining facing the vise. So let me clean that. Remove these ones. I need to check the setup to check where is the origin. Most likely it's on the top. It's the top left front corner. But let's try not to do any more fuck ups today and actually check the setup sheet. So we are doing the nuts. Yes, so exactly. It's the top left front. So we are good. Let's put in not anything fancy, so I only need one parallel for this. I don't even need to set it. I'm gonna remove the parallel because hardened steel doesn't match well with drills. So program top exec and let's probe it. There we go. And we'll Z go down X Y, Z, let's set the Z. Done, so set coordinates X 0. Let's move up the let's set the Z. Set coordinates Z0. And now let's set the Y. There's nothing there, so we are good. Let's set the Y to 0 as well, and we are on. Manual, move the machine away. Okay. So first tool, it's tool 12. So it's the long 6mm mill. Where is the long 6mm? It's here. Bunch of tools we are using today. So it should be this one. It should go 30 deep. Yeah, that's plenty. Should have like 40 almost. So we are good. Let's go auto and go. Let me go slow. Shake, make sure everything is fine. Looks like not. Didn't I set the Z0? Okay. Spindle stop. Manual. Did I forgot to set the Z? Let me check. MDI tool 0. I know I set it. Probably, maybe I forgot to set it on a DRO. I don't think so. Or maybe I set the wrong axis. Manual, and let's check. Or I'm selecting the wrong tool. Z is fine. Oh, okay. I know exactly what's going on. Okay, I see. Yeah, so it's the tool 12. I need to renumber this tool. It's tool 12. It's the one that I replaced by the M4 top. So yeah, I need to set it again. I knew I should save it. So it's minus 42.89. I need to renumber it. Minus 42.89. Not now though. Okay. That was the problem. Should be fine. We should be, yeah, about right. Yeah, so the problem was I remembered that tool for the M4 top, and actually it's a tool in use, so that was the problem. Not a big deal, but so this should be just two countersunk holes or counterbore holes and two spots and two drills. If I would be any smart, I would only do the counterbores in here. And I would do the drills and the spotting on the other side. But that's only if I was smart. Oh, we have some engraving to do. We have some engraving to do in here as well. If I remember correctly. So what's now? Tool 2. Okay, so it's gonna do some spotting down there. And should do the chamfering on top. And now 232, which I have no idea if it's good. Let me check which one is the tool 32. Tool 32 should be a chamfer mill. I'm pretty sure this one, it's not it. Where's my flashlight? So I can dive into uh-oh, that's a problem. I guess I retooled it. Okay. I did. Which one is bigger? Fuck, it looks the same to me. Oh, okay. That's a big problem. That's a big fucking problem. Need light. They look exactly the same to me. So Where is my magnifier? Training? Looks like it's raining. Need to set this on the table, sorry. I'm just checking the tools with a magnifier. Try to spot the difference. Actually, this one is bigger. Okay, let's check. Worst case scenario, it won't be the right tool, but if I do it slowly, I can check it. Actually, let me check something first. Last Alutech. Yeah, LGU. Alright. Yeah, that's fine. Nope. Fuck. Last. So this one. Okay. 12. Fuck. I'm pretty sure this is the wrong tool, but we'll find out in a minute. Yeah, this is the wrong tool. Well, this isn't my shop, it's not in my home, but yeah. Okay. That sucks. That sucks. So how can I fix this? How can I fix this the fast way? The fast way is changing this thingy to T30. The little doesn't really matter. It's only 3 letters, but let me check. So it should be close to the end. Well, maybe it's not that close to the end. So it's here. Yeah, it's here. So 30. This doesn't really matter. 5, and here it's what matters. It's T30, T30, 30, H30. Yeah, this is what matters. Everything else doesn't matter. I think I only have one pass. Yeah, this is the chamfer, so compile, fine, auto, manual. So I'm gonna run the machine. I need to run the program from the start. I probably can run from a specific line. I don't know. I never needed to do it. So the program is small anyway. I'm gonna disable the coolant, max feed rate. And just air run it. It's the simplest way. It should be able to start from a specific line, but I never actually looked out to do it. Probably it's in a single here. No, it shouldn't be single, it should be line by line. Not sure. Never tried. Never actually needed. Now should be the chamfer tool. I could go home and make a simple program for this, but it would take longer than just wait for the this thing to finish. So tool 30 now. I think this is the tool 30. I can't be absolutely sure, but so we are about 9 millimeters in. Looks good. Yeah, it should be this one. This is just a simple engraving. Three letters. They're gonna be a little bigger since this is supposed to be with a 0.3 engraving bit. This is the 0.5. It will be fine for all the intents and purposes. This is just for marking the XYZ nuts. So we are good. What time is it? Yeah, we're gonna finish about 2 AM. That's fine. So we have engraving. Exit's not really centered. Very smooth. We're good. I don't think we're gonna need this again, so I'm gonna put it away. I'm pretty sure we don't. Okay, so next. So we finished this side. Let me blow. Like that. So now should be the bottom, I think. I should have placed the magnet, I forgot. So we're probably gonna need to... Not probably. For sure. We're gonna need to measure X. Let me check. What's the third setup? Yes, so it's again the top front left corner. So X, Y and Z should be the same. We need to remeasure X. So let's do that. Okay, so set coordinates X 0, manual Z up, and let's see, probably it's tool number 2, bottom, yeah, tool number 2, do some spotting. Probably we're gonna need some new tools next. Let me check first. Yes, we're gonna need tool 90, 4.6 and T11 M5 tap. Okay. There we go. Okay, 4.6 should be probably that one. Yep. 4.6 is 3122 negative. So 290. Clear. 290, yes. Minus, what was it? 31, yeah, 3122. 31.22, enter, yep. Okay. We are almost full of tools in here. we go. Okay. And now we need the M5 tab, forming tab. So M5 forming tab. Which is M5 form 537 negatives. So 211. Clear -5 point, and I don't remember again. 24? No, 37. 37 negatives. And we need some stuff. Let me check something. Okay. So we need stuff in here, stuff in here, stuff in here, in here, in here. And let's go. Yeah, that's fine. And that's it. I'm gonna actually run the top again with a manual to make sure I bottom out, because those are really small threads. So I'll do that off camera, just to make sure that we get to the bottom of the thread, because they are very small. And I don't want to push the tap against the stock with the machine. But yeah. Fine, so last is the back. I assume it's like that. We're gonna check. Yeah, it's absolutely centered. I will need to make those deeper, which will be fine. So let me check the last setup. Yeah, as expected, and it's on the bottom. Okay, that's good. Good to know. Okay, so we gonna need something like, what's the Z minimum 12? Okay, that's fine. So I can use the 40 millimeter. Parallels. Make sure floor is clean. It's kind of important now. Okay. Do I have access? I kinda do. Yeah, I do. So I'm gonna hold it like, it's like that, right? Yes. Good torque. Let's hammer it to make sure the parts sit flat with the parallel. Everything sits flat. Parallel should be stuck. They are. And yeah, let's measure. So it should be the bottom, front, a left corner. So basically that corner down there. Let's load the program. Manual and wheel. Well, actually manual first. Let's jog it there. Closer. Fine. And wheel. Okay, I'm gonna jog to Z now. Yeah, that works wonderful. A little bit more there. Fine. Let's set the Z to 0. Now let's move up. Let's use the jaw of the vise to set the Y. There. That's pretty much dead on. Okay, that's fine. 4 microns off, I can live with that. Now we need to set X, which is a little more tricky, but fine. We're gonna use our gauge. Not really our gauge, our block. It's flat. No. there. So let's set x minus 20, since it's the 20mm size of the block, and we are good. Manual Z up, and let's start the program. Auto start. So first we need a tool 1, which is the face wheel. Nah, I'm a pussy with that. Face mill. And yeah, everything looks fine. There we go. Send it. Send it. This is not a huge spindle motor, so this thing is 5.5 kilowatt spindle, but that motor weighs like 35 kilos or something like that. It's actually capable of overloading to 7.5 kilowatt for 20 minutes, maximum continuous, which is pretty decent for me. It's good enough for the machine. I'm happy with it. Not sure what he's doing like that, but if I programmed it to do it, something was on my mind. I really don't remember doing that. Oh, it's because these two are, okay, I see. These two are smaller, that one is thicker. The first one is thicker. It must have been a reason for me to do this, so I was like, what the fuck? Makes sense. Makes sense. Makes sense. Okay, so now tool 3. I believe this one has some kind of step on it. I'm not sure if I remember correctly. I'm kind of concerned about the next operation though. Exactly. But can't be a loud crack. It needs to be just a little. Yeah, I'm kinda concerned about this guy. Let me check something. I think I fucked up. I may have fucked up. Well, it's not a big... Oh shit, yeah, I fucked up. I really did. I really did. Fuck, how can I solve this? So my problem is, I fucked up. I didn't remember about the chamfer tool. So the chamfer tool, the Z minimum, it will go, it's 9.2. And so that's 9.2 from the parallel. And my vice is at 10. So when it's gonna do the chamfer on this part, it will hit the vice. And I really don't want it to hit the vice. I should have set up bigger parallel. It's fine for everything except this guy. So what I'm gonna do, I need to go to my computer, and I'm gonna make a path with everything except that part in there. I can do it. I just can't. Okay, I need to go. Nah, I'm not gonna add soft jaws and re-zero. No need. That's a way overcomplicating the problem. I'm just gonna... I need to go recalculate. I'm gonna stop the program here. I should have used just bigger... the next size of the... parallel bars. So I'm gonna stop the program. I'm gonna leave everything. So give me 2 minutes and I'll fix this. So program, system, exact. So give me 2 minutes, I'll be back in 2 minutes. Yeah, because they are separated. So yeah, 2 minutes I'll fix it. It's just a little hiccup. It's not a big deal. I can do everything the same. I just need to reprogram the height of the tool for that chamfer. I should have like 2 millimeters. Let me check. Yeah, about 2 millimeters there. I can make that work easily. So give me 2 minutes. I'm back. I'm back. Do not worry. I'm back. Hopefully with a solution. Otherwise my jaws will receive some new tattoos. Not the first time. For sure it won't be the last. Okay, so we need to go to USB disk, PMSP, Milo, machining nuts, and fix. Yes, it's the same value, but should be fine. If I didn't fuck up. I hate doing programming at these hours, but should be fine. So first code should run exactly like that. Exactly. So it should do the second one next. Fine. Now it should do the rest a little higher. If I collect, yes, that's fine. And everything else should be as it was. Fusion at its best. I forgot I could have had something. I could chamfer the spot, or should spot the thread holes as well, but yeah, never mind. Not going there again for that. I don't know. Since I'm there, I should have spot them already. Okay, let me write the fix for... I'm not spotting these, but I'll spot the next ones. Okay, so machining nuts. Nuts. So back. Yeah, back. Two stuff. So I have the finish T3 and add spots. So we are off. So we have our little shiny, oops, sorry. A little shiny why not? Fuck. Let's see if it fits on a ball screw. It helps, right? It would help a lot if it fits. It does. With some play, which is intended, like a glove. And is it supposed to fit? Not in our case, because we're gonna use this thingy in the middle of the nuts, which actually it should fit as well with some play. So we are good in here. These are the bigger gap ones. Good, bueno. So we fit the, where is the, did I place it here and there? So the two washers for preload fit inside there very fine. So it should be good there. And what more? Nothing more. Everything should be fine. Let's remove the other two. So, are they parallel? That's kind of important. Let me grab the micrometer. Where is the mic? Not here. Mike, where are you? It's here. I see it. No, I don't see it. Mike. Where's Mike? Not there. That's weird. Not in his house. Where is my mic? Mike. I know I have one at home, but the other one should be here. Mike. You guys seen my mic? Not in here. If it's not there, is it in here? Shouldn't be. Nope. Oh fuck. Where did I last use my mic? not on my pocket. My mic is gone. My mic is gone. Let me check better. With good... What the fucker, where is my mic? Not in here. Not... Well, let me grab another one. Okay, where do we have another mic? Probably here. 25mm mic. Of course, this one doesn't have a battery. Why should it? Let me grab a mic from a battery from another mic. Anyway. There we go. We have a mic. Sorry. Where's my goddamn mic? I'm really concerned. Because I have no idea where it can be. This is not as good as a mic, but actually it's a shitty mic. I need to find a way to... Battery is low? Okay. Why doesn't that surprise me? God damn it. Okay, so this thingy... 1195. Oh, look at that, it's parallel. 1195. It's actually very parallel. Even for my standards, very parallel. Oh yeah, we are gold. Let's see the others. I'm like, no, actually I'm spot on. So 98, 98, 98. Oh yeah. Oh yeah. Spot on. Let's check the X. So 98.4, 98.5, 98.7, 98.4, 98.5. Yep, we are golden. We are golden. No, do not kill the mic. Okay guys, so that's it for today. Let me remove the tool. Let me make sure I... Power off. Shut up. Been along. So that's it for tonight. Tomorrow, probably, depending on my health state, I might be streaming a little earlier because I really want to get this done. Or not, if I'm too sick, depends. So yeah, we are done for this. I only need to do some deburring. Looks like good. These are cute, very smally. And all branded. So yeah, I need to finish the threads by hand, but that's fine. Tomorrow I may do one after lunch actually, like at 2 p.m. for us, maybe 3 p.m. and then maybe until 6, 3-hour stream, yeah, probably. And then again at 9 p.m. So probably tomorrow, if I can, I'll do 2 streams. So guys, thank you for watching. Hope you guys learned something, or at least liked what you've seen. It was some fun. Some mistakes, but that's happened. The prototypes anyway. So thank you for watching, and see you tomorrow. Bye bye.